Uh, for question number one, if sparklium, if sparklium, a fictional element, is known to be a transitional element, determine the proper ionic compound and then name the compounds below. The first two compounds we are given is sparklium and iodine. In order to combine both of these compounds and find its chemical formula, we must neutralize their charges. Sparklium's charge is a +6, while the iodine has just a single negative charge. Thus, we will need 6 iodides in order to cancel out the 6 positive charge from the single sparklium, giving us the chemical formula of SpI6. Now, in order to find its chemical name, we must recall that when we're naming a transitional element, we're going to be using Roman numerals instead of using prefixes and suffixes. Thus, the transitional element will always be the cation and come first, while the second element will be an anion and having an IDE ending, leading us to the name of sparklium, Roman numeral 6, iodine. Now, for the second part of the question, we're giving. For the second part of this question, we have one sparklium, which has a +6 charge, and given one oxygen, which has a -2 charge. Once again, we're gonna need cancel out the +6 charge of sparklium, which means we'll need 3 oxygen, giving us the chemical formula of SpO3. Now moving along to the chemical name, it's going to be once again using Roman numerals, and the second element is going to have a IDE ending, leading us to the name of sparklium, Roman numeral 6, oxide. Now moving on to question number 2. In question number 2, we're given two non-metal compounds, thus making it a covalent bond. Once again, we'll need to neutralize their charges. And once we neutralize each other's charge, we're going to be using 1 calcium, 1 glitterium, which will mean we'll just have the chemical formula of calcium glitterite. Now, in order to determine the order of each pairs of which element comes first, which element comes last, the positive element will always come first. Now, moving on to naming the chemical formula. Since whenever we're naming covalent bonds, the chemical name will use prefixes and suffixes rather than Roman numerals, while the second element will have an IDE ending, leading us to the name of calcium glitteride, as we only have 1 calcium and 1 glitterium. Moving along to the second part of the question, we have hydrogen and we have glitterium. Once again, we're going to need to neutralize the pair, thus we're going to be needing 2 hydrogen, leading us to the chemical formula of H2Gl. As a +2 charge of the hydrogen will cancel out the -2 charge of the glitterium. Thus, the chemical name is going to become hydrogen glitteride. Now, in question number 3, we are once again tasked to name 2 covalent bonds, and as stated before, we have to match the amount of atoms to its numerical prefix. For example, For example, 1 will equal mono, 2 will equal di, 3 will equal tri, so on, so on. So, within this chemical formula, we have 1 potassium, and we'll have 5 phosphate. Thus, it'll give us the name of, 5 phosphorus. Thus, this will give us the name of potassium pentaphosphorus, as penta will mean 5. And this will be the same for the second part of the question, as we'll have 3 potassium and we'll have 7 chlorine. Thus, with the 3, it'll equal tri, giving us the name of tripesium, heptachloride. These will be the names for our chemical formulas. Moving along on question number 4, we have to calculate the following for the compound you created from Sp and oxygen, sparkling and oxygen. Though we can recall that we already did this before, and that gave us the chemical formula of SpO3. So we can just write this alongside here for safekeeping. In the first part of the question, we're going to need to find its molar mass. And in order to find its molar mass, we have to find the atomic weight for each individual element and multiply it by its weight. And for the molar mass, we need to find the atomic weight of each individual element. So we're going to be using oxygen and sparkling. Oxygen's atomic weight is just 16, while sparkling's atomic weight was 104.35. Now we need to multiply its atomic weight of each element by the amount of the element that's within the compound. As such, we have 3 oxygen and just 1 sparkling. Thus, our oxygen is going to be multiplied by 3 and our sparkling is going to be multiplied by just 1. We'll add the products of both together, which will give us a molar mass of 152.35. Now for part B. In order to find the amount of grams in 1 mole, we have to use a stoichiometry and set up the problem so that we'll be multiplying by 1 mole over Avogadro's number. So we can set it up as 152.35 over 1 mole of SpO3. This will be grams, so it's going to be SP3 as well. You can multiply this by 1 mole of SpO3 over the Avogadro's number. And this will give us the answer of 2.52989, E negative 22 of grams per molecule. Now in part C of the problem, we have to find the amount of atoms within 80.9 grams of SpO9 of SpO3, and we have to convert this amount of grams to moles. So we can set up the problem as so we find the moles, and this will give us 0.553 1044 moles of SpO3. We're not finished yet. Then we'll simply multiply the amount of moles by Avogadro's number to obtain its molecules. And lastly, we'll multiply the product of those two by the amount of atoms within the molecule. So and multiplying it by the amount of atoms. And it's best to just visualize this, as there's going to be 1 sp, while there's going to be 3 oxygen. Thus, it's going to be a total of 1, 2, 3, 4 atoms. Within one molecule. This will give us the answer of 1.27911 e to 24 power atoms. And lastly, in part D of the question, when attempting to find the number of moles of ions within 27.01 grams, it's very similar to the last problem. Though when finding moles of ions, we're simply just going to skip converting it to molecules and go from molecules times the amount of ions within one molecule. So we can set it up as so. 27.0 grams SpO3 over 1 times 1 mole of SpO3 and we'll just simply times it by the amount of ions. And as last time, it's best to just visualize it, as there's going to be 4 ions over 1 mole of SpO. The amount of moles is going to equal 0.17729 moles of SpO3 times 4 ions, which will equal 0.7092 moles of ions. Alright, for question number 5, I believe it would be best if I just went over my process, as I think it will be too time consuming if I just went along as I wrote. So in question number 5, we are tasked with determining the reciprocal formula of the compound. As we take 1.2894 grams of an unknown sample, and it combusts to create 0.6028 grams of carbon dioxide and 0.3085 grams of H2O, and also 0.8712 grams of glitterium. First, we'll need to determine how much carbon and hydrogen was created and subtract the total created in order to find out how much oxygen was also created. And then thus, firstly I need to find the atomic mass of carbon dioxide and simply convert the amount of grams which was created from the combustion of carbon dioxide into moles. And that's how I found how many moles of carbon dioxide was created. Next, I times that by an amount of carbon which is within carbon dioxide, which is just 1, leading us to the amount of moles of carbon dioxide created from the combustion. Though we're not finished there, we need to keep the moles of carbon dioxide in a safe space for later. But next, we'll need to convert the moles of carbon dioxide into grams. Thus, we'll just times it by the molar mass of carbon dioxide, leading us to the number of 0.1645 grams of carbon created from the combustion. Next, I did the exact same process but for H2O, as I found the molar mass of H2O being 18.02, and I converted the amount of grams created from the combustion into moles, thus giving me the number of 0.1712 moles created of H2O, and I times that by an amount of hydrogen that's within H2O, which is 2, giving me a total number of 0.03424 moles of hydrogen within that came from the combustion. And again, I times that by the molar mass of carbon, which gave me a total of 0.03458 grams of hydrogen produced from the combustion. And again, we're going to need to add both hydrogen and carbon together, both the grams, and subtract that from the total amount of grams from the unknown substance in order to find the amount of grams of oxygen that's within that's within the combustion as well. Though we can't forget about glitterium as well. Once we added all 3 elements of carbon, hydrogen, and glitterium, we subtracted that from the total and got an amount of 0.21912 grams of oxygen. And again, we just converted that into moles of oxygen by just dividing it by the molar mass of oxygen. And in order to once we have found the amount of each element created, we must convert the elements to moles and divide each element by the lowest mole amongst them. Once we have found the amount of each element created, we must convert the elements to moles and divide each element by the lowest mole amongst them. As such, (697) H equal oxygen equal 0. I need to make this smaller. Oh, and I almost forgot, we needed to convert the amount of glitterium into moles, as the combustion had 0.8712 grams of glitterium. We converted that amount of grams of glitterium into moles. Now, going amongst these values, we can see that glitterium has the lowest amount of moles compared to the rest of them. As such, we'll divide all the rest of the moles by the lowest amount. And dividing each one will give us the answer of combining each of these together gives us the formula of 2 carbon, 5 hydrogen, 2 oxygen, and 1 glitterium. I could probably write that better. Thus finishing the problem.